Okay, today we are learning about graphing linear inequalities. So y'all know how to graph lines. Now we're graphing inequalities. I know I've got this when I can graph a linear inequality in two variables. So let's go over some of the key vocabulary. A linear equality in two variables can be written in the form ax plus by is less than c. And then of course that inequality can be switched out for any other inequality sign. The solution region is the half plane that satisfies the inequality. If the line is solid, the coordinates of the line are part of the solution region. If it's dashed, it is not part of the solution region. Half planes are the two planes of the xy coordinate. The boundary is the line of ordered pairs that splits the graph in half. One half contains ordered pairs that satisfy the inequality and the other half does not. A test point is a coordinate that's used to determine which half plane to shade. All right, an ordered pair is a solution of the linear inequality that makes the inequality a true statement. The boundary line is dashed for less than or greater than and solid for less than or equal to and greater than or equal to. Okay, go ahead and read this, pause it. All right, so let's do number one together. Well, I'll do this one for you and then we'll do the next one together. All right, so you're gonna graph this on the graph just like you would any other line, okay? So I can subtract 7x from both sides and I would get y is greater than negative 7x, it's supposed to be an x, negative 7x minus 14. Now, what you'll see about that is this graph actually only goes to negative 12, so we're just kind of going to estimate that would be negative 14 down there. And then negative 7, we would go down 7 and over 1 or up 1, 2, 3, 4, 5, 6, 7 over 1. 1, 2, 3, 4, 5, 6, 7 over 1. Okay, so we are making a line. We're going to draw a line through these points. As best we can. Okay, now what I want you to see is that actually is a straight solid line. We really need a dotted line. So I'm just going to come over here on top with black so that you can see that this is really a dotted line. And the reason that it's a dashed or dotted, whatever you prefer, is because this is greater than. It's not greater than or equal to. Okay, so if you have greater than or less than, you're going to use a dashed line. If you have greater than or equal to or less than or equal to, you're going to use a solid line. Now what you're going to do is you're going to use a test point to solve this, to see which area you need to shade. The best test point to shade, to always try out is 0, 0. So what that means is if I plug in a 0 on this graph, okay, so like if I plug in a 0 for x and a 0 for y, is the statement going to be true? Is 0 greater than negative 14? Yes, it is, which means that I can shade the area of the graph that 0, 0 lies in, and that is it. That's how you graph it. That's it. Okay, and you can see that works. So we just put it in slope-intercept form, or you can just plot coordinates if you want to. You can just plot, just x's and get your y values. You can do that. It's a dashed line if it's less than or greater than. Solid line if it's greater than or equal to or less than or equal to. Then you test a point. If the test point makes it a true statement, you shade that area. Okay, let's try another one. All right, so on this graph, we're gonna graph this line. So I'm gonna put this in slope-intercept. So I'm gonna subtract the 3x from both sides. I'm gonna get 5y is less than or equal to negative 3x minus 2. Divide everything by 5. So I get y is less than or equal to negative 3/5 x minus 2/5. Well, that's not a great y-intercept. So it's negative 2/5. We'll put it about there. And then we go down 3. So 1, 2, 3 over 5. So 1, 2, 3 over 5. So it's going to be about right here. And we're going to use a solid line because it says it's less than or equal to. So I'm going to draw a solid line this time through those points. And you can come back on top of it with a dark pencil and shade in if you want to. So we know it's a solid line. Okay. You can do that if you want. And then you're going to shade. So 0, 0 is right here, right? So if I put in a 0 plus a 0, is that less than or equal to -2? No, it's not. So that would be a false statement. So I'm actually going to shade the other side of the line. So if my test point 0, 0 did not make that a true statement, because 0, 0 is right here, right? So if that did not make it a true statement and 0 is not less than -2, then I'll shade on the other side of the border. So the line itself is called your boundary line. And the half plane, so I have a half plane that's shaded and a half plane that is not. So that's kind of the vocabulary that goes along with this. All right, let's go ahead and do this one. And I know you see it over here, but let's just pretend you don't, okay? So if I divide both sides by 3, I get x is less than 5. So I'm going to go to 5 and I'm going to draw a dashed graph because it's less than, it's not less than or equal to. And then if I put a 0 in place for the x, would 0 be less than 5? Yes. So that means that I shade the area that 0, 0 is on. Also, think about all the numbers less, and in this case, I don't even usually do test points when I'm doing it for myself. I just think, okay, if x is less than 5, I know 4 is less than 5, I know 3 is less than 5, so I'm going to shade to the left of the graph. And then this, okay, so this graph, you're supposed to be doing it by yourself. So is it dashed or solid? It's dashed at y equals -2. And then you're shading everything greater than -2. So you would shade up here. And then you're not supposed to have those points below the line. So we're just gonna, well, I don't want to get rid of those. You're only supposed to shade above the line. So it actually looks like this. And that's a prettier graph. Okay. So here's some extra practice. Go ahead and see on 2A through D, what you're doing is you're taking those coordinates and you're plugging them in one at a time in for the X and the Y, and you're seeing if they work. Okay, so you're seeing if those are solutions of the inequality. All right, pause the video. All right, so I know I've got this when I can graph a linear inequality in 2 variables. Do you really understand? What is the difference between the graph of y is greater than 1/2 x plus 4 and the graph of y is greater than or equal to 1/2 x plus 4? The only difference would be that your line is going to be dotted on the first one. It's going to be dotted when it's greater, and it's going to be solid when it has or equal to with it. All right, explain how you would decide which boundary line to shade when graphing the inequality. Okay, so you can choose a point not on the line, such as 0, 0, to use as a test point. If the inequality is true, shade the boundary line that contains your test point. If not, shade the other side. That is it. I hope that helps. Let me know if you need extra help with that.